All right, so the previous section talked about first derivatives in regards to max, min, increasing, and decreasing. What this last section that's going to focus on the last part of graphing is going to talk about something called concavity and points of inflection. So concavity is the curvature, basically, of the graph. Do you have a happy face? Do you have a sad face? Is it a smile? Is it a frown? And this is going to focus on the second derivative. So the nice part is the process is going to be exactly the same as what we did for first derivative. We're just now doing it again, basically. So if the second derivative is greater than 0, then we're going to be concave up. And so what I always suggest is think of a smile. So this would be concave up because it's like a happy face. Okay. And if our second derivative is less than 0, that means it's going to be concave down. And then I say, okay, well, opposite of smile would be like a frown. So you want to think of a frown. So that would be upside down. It's not a full frown, but it gives that appearance of a frown. All right, so the inflection points, though, there's an inflection point if the concavity changes. So with first derivative, we had learned there was a max or a min if it changed from increasing to decreasing or decreasing to increasing. For points of inflection, we just need there to be a change in concavity. So again, what we're about to do is going to be very similar to what we did with first derivative. The only difference is we're only going to focus on second derivative right now. So it says find the points of inflection and concavity. So we have our original function. First, we're going to get the first derivative, which is 4x to the third minus 12x squared. But then with concavity, we need second derivative. So we get 12x squared minus 24x. We're going to get critical numbers, so we're going to set that equal to 0, factor out a 12x, and you have an x minus 2 left over. And you have two critical numbers, 0 and 2. Just like we do for first derivative, those two critical numbers go on a number line. And we test. Now keep in mind, though, we're on second derivative, so we are testing in the second derivative. And when we test, I'm going to get a positive, a negative, and a positive. So we are looking for concave up, concave down, and inflection points. All right, so concave up is like increasing. Where are there plus signs? Well, that's negative infinity to 0, union with 2 to infinity. Concave down is like decreasing where there are minus signs, so 0 to 2. And an inflection point is where there is a change in concavity or a sign change. So there's a sign change that occurs at 0, and there is also a sign change that occurs at the 2. So 0 goes back into the original, so you get 0, and 2 goes back into the original, and you get negative 16. So just like with first derivative, when you test, they go into the derivative you're focusing on. When you're finding points, you go back to the original function. All right, let's try another one. So we've got our original function here, 2x to the fourth minus 8x plus 3. First derivative, 8x to the third minus 8. Second derivative, 24x squared minus 0. So done. Set this equal to 0 and you get one critical number at 0. That critical number goes on our number line. And you can even abbreviate. You don't need to write the whole thing out. Inflection point. Okay, and we're going to test. Now when we test, what you're going to find is that it doesn't matter which side you go on, you're going to get a positive for both. Okay, so if you get a positive for both, that means you are going to be concave up everywhere. So that's from negative infinity to positive infinity. Don't write it as two separate intervals. If you're concave up everywhere, then you're concave down nowhere. So there's none. And then if there's no sign change, then there is also none for inflection points, or none for that. Okay? So again, there has to be a sign change for the concavity to have one of each. And same goes for the inflection points. All right, so as always, throw in that trig one in there. So we have sine x plus cosine x, First derivative gets me cosine x minus sine x. Second derivative gets me negative sine x minus cosine x, which I'm going to set equal to 0, and I'm going to bring just 1 to the other side. So we had a question like this in the previous section. So we are looking for where the sine function on the unit circle and the cosine, so the x and the y, are the same number. They're just opposite signs. So that's second and fourth quadrant, same idea. It's pi over 4 again. So we have 3 pi over 4 and 7 pi over 4. So those two values are now going to go on our number line. And just as I said with the previous section, test the axes. Make it easier for yourself. And when you test, we should be getting negative, positive, and negative for our signs. So if we are talking concave up, we have the one interval in between from 3 pi over 4 to 7 pi over 4. Concave down, there's two intervals, negative infinity to 3 pi over 4 and 7 pi over 4 to positive infinity. And you have two opportunities for a sign change, which means you have 2 inflection points. And you are going to take those values and sub them into the original. So these go back into the original, and what you'll find is you end up with 0 for both of them. Okay, so the question is, where are we going with all this? So now we're going to put it all together. So this last example, we're dissecting and we're going to sketch the actual graph. So we are finding everything that we've now covered over the past 2 days. So we're going to make 2 different sets of information in terms of data that we're going to collect. The first one is going to focus on the first derivative. Second piece is going to focus on the second derivative. So if we do first derivative first, we get negative 3x squared plus 12x. We're going to set that equal to 0. Pull out a negative 3x, and you have an x minus 4 left over. So you have 2 critical numbers, 0 and 4. Those 2 are going to go on a number line. And remember, first derivative tells me 4 things: max, min, increasing, and decreasing. So now I'm going to test in the first derivative. When I test in the first derivative, I get the signs of negative, positive, negative, which means I have a maximum at 4. I have a minimum at 0. I am increasing on the interval 0 to 4. I am decreasing from negative infinity to 0, union with 4 to infinity. And then I'm going to take the 4 and the 0 and sub them into the original. 4 gets me 27. And 0 gets me negative 5. So that's just the data I collect from first derivative. Now I'm going to repeat the process, but with second derivative. So my second derivative would be negative 6x plus 12. Set that equal to 0, and I get a critical number of 2. I take that 2 and I put that on a number line. And remember, second derivative tells me 3 things: concave up, concave down, and my inflection points. And when I test, I get a positive and a negative. Remember, you're testing in the second derivative. So concave up is negative infinity to 2. Concave down is 2 to infinity. And there is a sign change at 2, so that is an inflection point. So I plug that into the original, and I get 11. So now we've collected all our data. So now what we are going to do is we're going to sketch it, an accurate sketch. So what you want to do, first thing you want to do is plot the points. So you always say, how many points do I have? Well, this is a point, this is a point, and this is a point. So those 3 things you want to plot first. So again, some of these are very high, so just guesstimate. 1, 2, 3, 4, and we'll put 427 up here. 0, negative 5. 1, 2, 3, 4, 5 down here. 0, negative 5, and we have 211. So 211 somewhere in the ballpark here. All right, now 211 is an inflection point, IP. 427 is a max, and 0, negative 5 is a min. So a maximum is like a hill in the graph. A minimum is like a valley, so a low point. Now, the last four things we have to account for are intervals of increasing, decreasing, concave up, and concave down. Honestly, I think if we focus on concavity next, it's a little bit easier, and then you'll be able to double check to make sure that it actually matches up with increasing and decreasing. So it says, now my inflection point is 211, so this is where right here that the concavity is going to change. Anything prior to that point, so anything on the left-hand side, tells me that I'm going to be concave up, which means that should be a smile or a happy face. So I'm going to make my smile. Okay, so again, anything to the left of 2, so from negative infinity to 2, gives me the appearance of concave up. That's my happy face. Then what happens at 211, anything after 2, so 2 on, is now going to be concave down. And so this is where your happy face turns into a frown or a sad face. But you have to go up to that highest point and then hook it around. So here is your concave down. And then the last part you could check on is, does increasing or decreasing make sense? So I should be decreasing from negative infinity to 0, which I am. I'm coming down here. Then I'm also decreasing from 4 to infinity, which I am over here. And then the last part is it's saying that everything in between from 0 to 4, I should be increasing.